Greetings. My name is Dr. Boyd, and I'm coming to you on behalf of the Transformational Education Adventure Center, also known as the T Center, located in McLean, Virginia. And today we'll be doing another STEM lesson. Today, our lesson is about freezing and melting. Freezing and melting. And if you want to follow along with the demonstration, here's what you'll need. You're going to need some salt. You're gonna need a glass or a cup. Choose one that is transparent, I guess, so you can see it. And then you're gonna need some ice. I have some ice here, some ice blocks. And you're gonna need some string, all right? And not a lot of string, maybe about 6 inches worth of string. Okay, so freezing and melting, these are things that we encounter throughout the course of the year. And in fact, if you take a glass of water and put ice in it, you're witnessing that process take place right before your eyes. So it doesn't have to be cold or have strange weather conditions outside for you to experience freezing and melting. So what is freezing? What is melting? And when do these things happen? Okay. The act of freezing is what we call an endothermic reaction. That's endothermic reaction. That means that heat from the surrounding environment is being pulled into something, like an ice cube. All right, so an ice cube is heat is being pulled into the ice cube. Well, when that happens, that causes the ice cube to melt, right? Because the ice cube now is being warmed up by the external heat. Okay, the opposite of an endothermic reaction is an exothermic reaction. And that is when heat is being given away to the surrounding environment. And lots of things that we are familiar with do that. Even something like the bouncing of a ball on the ground actually gives off heat to the surrounding environment. All right, so what can you do with freezing and melting? Well, believe it or not, you can actually change the temperature at which something freezes, like water. Water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. All right, so 32 degrees Fahrenheit is the same as 0 degrees Celsius, and that's what we call the freezing point of water. But did you know you can change that value, right? You can change it by adding salt, or at least in simple terms, we claim, or it seems that we're changing that value to something else. Well, by adding salt, you decrease the temperature at which water freezes and the temperature at which ice melts. That means when I add salt to water, it won't freeze at 0 degrees anymore. It's actually going to freeze at a temperature less than 0 degrees, like say maybe -2 degrees Celsius, all right? Or maybe -28 degrees Fahrenheit. I'm sorry, not minus, but 28 degrees Fahrenheit. So what about the freezing portion? We know that the ice is freezing there at 0 degrees Celsius, but now I've added salt to it. So it won't be frozen at 0 anymore. Why? Because I've added the salt. And that's what we're going to be experimenting with today. The temperature at which water freezes and the temperature at which ice melts will be decreased because we're going to add to it some salt. And we're going to demonstrate that by trying to pick up a piece of salt with some string. I'm sorry, a piece of ice with some string. So let's get started. Here's my glass. Okay, and now with this cold water, I'm gonna take one of my ice cubes here and place it in the water. All right, I'll actually place a couple ice cubes in here and see if one of these will be a good candidate to use. All right, so I have ice cubes, which are cold. Obviously, ice and water are related because They are both made up of the same molecules. Water is sometimes referred to as H2O, but ice is also H2O. One is a liquid, that's water. The other is a solid, that's ice. And now I'm going to take this string, and if you're following along at home, what you want to do with your string before you attempt this is you want to put it in water. You want to make sure that it's already wet. Now, I have placed it on top of an ice cube. I've placed it on these ice cubes in here, and nothing seems to be happening. Like nothing is happening. I'm unable to pick up the ice cube. But watch this. I'm now going to take some salt and pour it along the string that's on the ice cube. All right, so I've poured some salt now here on the string that is laying across the top of the ice cube. I'll try to show you so you can see it a little better. All right, so I have string laying on top of these ice cubes, and I poured some salt along the surface of the string and the ice cubes. All right, and I'm gonna wait just a little while to see if I can get enough of the ice to melt so that it refreezes around the string and will allow me to actually pick up the ice cube. You saw before I was unable just to pick up the ice cube, but now I should be able to pick them up. Let's see if it worked. Check it out. All right. So why is this happening? Why am I able to pick up the ice cubes now? I took advantage of the fact that by adding salt, I can melt the ice. Okay, so by adding the salt, the ice melted. But because it's already cold, the water's cold and the ice cube beneath is still cold, it immediately freezes. The water begins to freeze again, but it freezes onto the string. This means now that we have frozen ice stuck to string, and that means I can just pick the string up and in turn pick up the ice. All right, so just to recap, salt decreases the temperature at which water freezes and ice melts. And by taking advantage of that, I can pick up a piece of ice by pouring salt on the string that is on top of an ice cube in cold water. All right, I hope you enjoyed this lesson today about freezing and melting. I call it ice on a string, so I hope you get a chance to try it out yourself at home. Also, follow the T Center on Facebook, follow our website, go to thetcenter.com, I believe it is, and definitely check out all the wonderful things that are happening at the T Center. And perhaps if you know some little ones, they can sign up and join as well. I will see you later.